Hello everyone. In this tutorial, we are going to learn how to convert rectangular coordinates to polar coordinates. Don't forget to like, comment, and share to other people. Let's get started. Here is our first problem. We would like to convert 2, 2 root 3 into polar coordinate, which is going to be r, theta, for which r here is the radial distance, the distance from the pole down to the point, and theta is the angle subtended. So first of all, we should determine the position of this coordinate. Both are positive, which implies that this is in the first quadrant. So if you have y and x axis like this, we have 2 for x, so 1, 2. Then you move up 2 to 3, assuming it is situated 1, 2, somewhere here. So this is what? 2, 2 root 3. All right. So what is this r? R will be the distance from the pole down to this point. So this is our r. We have to find it. Then theta is this angle from the standard position down to this line leading to the point. So let's start with the r. To find the r, we can always take the square root of x squared plus y squared. This is the formula. And this is my x and this is my y, right? So r will be equal to the square root of 2 squared plus 2 root 3 also squared. So let's simplify. 2 squared will give us 4. Then 2 root 3 squared, 2 squared is 4, root 3 squared is root 3, so we have 4 times 3, 12, and 12 plus 4 is 16. Square of 16 is 4, which implies that r is equal to 4. We are done with r. Then what about the angle, which is this particular angle here, theta? It is going to be equal to tan inverse, or let me write it like this. Theta is equal to tan inverse of y divided by x. The only thing you should know is that tan inverse will always return an angle from pi over 2, because this is pi over 2, negative pi over 2 to positive pi over 2. Irrespective of wherever the angle is located, whether it is in the second or third quadrant, it will not return an angle here, rather here. So I'm going to show you how you can bypass that as well. So because we are in the first quadrant, we know everything is going to be positive. So this is equal to tan inverse of this divided by that. 2 root 3 divided by 2. That is y divided by x. And you can see that 2 will cancel 2. All we have is tan inverse of root 3, which is going to give us either 60 degrees or pi divided by 3, right? So, okay, let me be interchanging them. So in this case, I'm going to use pi over 3. So we have our r and we have our theta. So you can confidently write them here. So we have 4, pi divided by 3. So this is rectangular coordinate, while this is polar coordinate. The radius, or the distance, or the radial distance from the origin to the pole, to the point, is 4 units, while the angle subtended is pi divided by 3. Let's move on to the second problem. We would like to convert negative 2 root 3, 2 into polar coordinates. I don't think, well, let me just draw it. Where is the position? You can see that x is negative, meaning we are moving towards this direction, but y is positive. We are in the second quadrant. So assuming it is situated here, I'm just assuming this is negative 2 root 3, 2. For instance, this is the point. Then we need to find the radius. The radius is always positive, right? Because if you square this, it becomes positive. So r will be equal to the square root of negative 2 root 3 squared plus 2 also squared. Negative 2 squared is 4. Root 3 squared is 3. 4 times 3 is 12. 2 squared is 4. 12 plus 4 is 16. Square root of 16 is 4, which means that r is also equal to 4 in this situation. Then, what about the theta? Remember, I told you that this is in the second quadrant, right? It will return an angle here because it will not return an angle here. But I'm going to show you how you can do that. This is tan inverse of y over x, right? This is y, that is 2 divided by negative 2 root 3. We are going to assume that all of these are positive. Therefore, it is going to return an angle here. But since we know that it should be in the second quadrant, we are going to take that value, subtract it from 180 or pi. It will surely give us this particular angle. And that's just the logic we are going to apply. All right, you can see that 2 will cancel 2. You can rationalize it, but it doesn't matter. I'm not going to do that. If you rationalize it, you can multiply the top and the bottom by square root of 3. But whatever the situation is, this input will eventually be negative root 3 divided by 3. But we are going to assume it is positive. If it is positive, what is going to be tan inverse of root 3 divided by 3? Definitely 30 degrees or pi divided by 6. But this is where it is going to be 30 degrees, right? But this particular angle is what? 30 degrees less than 180. So that's just the logic. You can pretend as if this particular value here is positive. If it is positive, it is going to return an angle to the first quadrant. But you personally knew that you are supposed to be in the second quadrant. So take that angle you obtain, which is 30 degrees, subtract it from 180, it will give you this angle. So therefore, this is going to be 150, right? 150 degrees. The moment you subtract 30 from 180, you're going to get 150. Yeah, definitely. Therefore, we have our coordinate to be 4, 150 degrees. And that is it. Let's move on to this particular one. We would like to convert -1, -1 into polar coordinates. This is what? Third quadrant. -1, -1. So we have our point here. So we're looking for the distance here. So r will be equal to the square root of -1 squared plus -1 also squared. All of them will be positive 1, 1. 1 plus 1 is 2. So our r will be equal to square root of 2. Then what about the angle, theta? Theta will be equal to tan inverse of -1 divided by -1 because both y and x are the same. So the ratio will be just 1. But remember that since it is positive, it is going to give you an angle here, which is 45 degrees. All right? If you take tan inverse of both sides, it will return 45 degrees or pi divided by 4. Let me use pi divided by 4. So if it is pi divided by 4, you can see that this is also a measure of pi divided by 4 greater than pi. So if you want to get this theta, because it must be in this quadrant, but it returns an angle of what? 45 degrees. Therefore, you have to add 45 onto 180. So it will be pi plus pi divided by 4, right? This time this is 4 plus this is 5. So we have 5 pi divided by 4 as your angle. So you can see that the polar coordinate will be what? Root 2, 5 pi divided by 4. So from this to this is rectangular while this is polar. And the last one, first of all, let us determine the position. You can see that x is positive 1, right? But this is negative root 3, assuming it is situated here. because it is negative, so y will be negative down here. So we are looking for this distance, r. Let's start with r. R is equal to the square root of x squared, that is 1 squared, plus negative root 30 squared. 1 squared is 1, negative root 30 squared is 30, plus 1 is 4, square root of 4 is 2, and hence r is equal to 2. Then the angle, which is theta, is equal to what? Tan inverse of y, which is negative root 30, divided by 1, which is just negative root 30. So if you take tan inverse of negative root 30, you can assume that this angle is too big from the standard position down here. So you can find that small angle in the first quadrant, then subtract it from 360, it will surely give you this angle. So what if we have root 30, just root 30? It is going to give us what? 60 degrees, right? Let me use degrees instead of radians because I'm interchanging them. Okay, let me use radian this time around because I could remember I used degrees twice. But notwithstanding, they are all the same, different conversions. So if you use positive, assuming it is positive root 30, it is going to return either 60 degrees or pi divided by 30. Let me take them simultaneously. But you should know that it's supposed to be here. So you can say that theta is either equal to 360 degrees minus 60 or theta equal to 2 pi minus pi divided by 30. Yes, this will give us what? 300 degrees. This will give us 5 pi divided by 30. Yeah, 3 times 2, 6 minus 1 is 5. So these are the two angles. So you can either write it as 2,300 degrees or 2,5 pi divided by 30. All the same. So this is how to convert from rectangular coordinate down to polar coordinate. So what if you want to convert it from this back to that? That should be in our next tutorial. Thank you for watching. Do share to your learning colleagues. Bye-bye.